Welcome back. In this sub-lesson, we are going to talk about OTV, Overlay Transport Virtualization. OTV is a MAC and IP method that extends layer 2 connectivity across the transport network infrastructure. That means you have an underlying infrastructure which is based on IP, and you are encapsulating your host traffic, which is a layer 2 traffic, into the OTV header and transmitting across the IP network in order to reach remote sites. An important thing to remember, before OTV, Layer 2 Data Center Interconnect, or DCI, Layer 2 DC Interconnect, or DCI, was achieved with the use of direct fiber links, configured such as Layer 2 trunks or 802.1q tunneling, EOMPLS or VPLS circuits. That's how it was achieved. Remove the part from butt width. And most of these solutions rely on potentially complex configuration by a transport service provider to become operational. Adding a site with those solutions means a service provider needs to be involved to complete the necessary provisioning. It's a lot of overhead. Because OTV is encapsulated inside an IP packet for transport, it can take advantages of strengths of layer 3 routing, such as ECMP paths or load sharing, redundancy as well. Not only that, and it simplifies the troubleshooting as well, because the transport network is traditional IP network, and a lot of tools and techniques are already there to troubleshoot IP networks. OTV supports both multicast and unicast transports. That means you can have the underlay working based on multicast or unicast replication. OTV uses ISIS as the control protocol. It uses ISIS to advertise the MAC reachability information to the remote sites, and uses ISIS also to build adjacencies across the OTV edge devices. OTV is supported on Nexus 7000 and Nexus 7700 switches. Apart from the Nexus switches, OTV is also supported on ASR 1000 series routers. In this sub-lesson, we are not going to talk about ASR 1000 series routers, but primarily focus on Nexus 7000 series switches. One other thing to remember and note is that on Nexus 7K, the Nexus 7K switches does not encrypt the encapsulated payload. OTV has two versions, 1.0, which is the non-standard one when it was initially introduced, and second one was version 2.5, which was introduced as part of the IETF draft. There are several keywords that we need to know when it comes to OTV. There is an IP transport network, there's edge device or AEDs, then there's join interfaces, internal interfaces, overlay interfaces, OTV site hellos or site IDs. The OTV site hellos are not just within the site but also across the site. That means these are the overlay ISIS hellos. Let's talk about all these terminologies in detail. OTV edge device. OTV edge device is responsible for dynamically encapsulating Ethernet frames into layer 3 IP packets for VLANs that are extended across the OTV. At each site, there can be multiple OTV edge devices which performs all OTV functions. On Nexus 7K, different licenses are required when configuring a device as an OTV edge device. It requires the transport service license, and if you're establishing or configuring VDCs as part of the OTV devices rather than standalone Nexus 7000 switches, then you would need advanced services license for creation of VDC. OTV join interfaces. The interface on the OTV edge device that connects to the layer 3 routed network and uses to source the OTV encapsulated traffic is called the OTV join interface. It can be a loopback, a layer 3 point-to-point interface, or layer 3 port channel interface. Remember that multiple overlays can use the same join interface. OTV forwards both the control and the data traffic using the join interfaces. The OTV join interfaces are supported on M series modules or F3 series modules. If you are planning to use OTV join interfaces on a different series module, it is not supported. You will require at minimum M series and F3 series modules. OTV internal interfaces. OTV internal interfaces are the interfaces on the OTV edge device that connects to the local site. This interface provides traditional layer 2 interface from the edge device to the internal network, and MAC addresses are learned as traffic is received on this interface. The internal interfaces is a layer 2 trunk that carries the VLANs being extended by the OTV. The internal interfaces are supported on M-series modules and all the F-series modules, F1, F2E, and F3 series. It is also recommended when you're deploying OTV to use the latest CCO software that is published and recommended. OTV overlay interfaces. The OTV overlay interfaces are the interfaces on the OTV edge device. The overlay interface is used to dynamically encapsulate the layer 2 traffic for an extended VLAN in an IP packet for the transport to a remote OTV site. Multiple overlay interfaces are supported on an edge device. The OTV overlay interface is a multi-access and multicast capable interface. Authoritative edge device, or we call it AED. The AED is responsible for forwarding the traffic for an extended VLAN across OTV. The AED advertises MAC address reachability for the VLANs it is active for to the remote sites through the OTV ISIS control plane. The AED is determined based on the ordinal value of 0 or 1, which means that the edge device with the ordinal value of 0 is the AED for all the even VLANs, and the edge device with the ordinal value of 1 is the AED for all the odd VLANs. This ordinal value is determined when the adjacency is formed between the two edge devices at a site and is not configurable. Thus, all this process is automatic. OTV site adjacency. The OTV site adjacency is formed across the site VLAN between the OTV edge devices which are part of the same site. If an ISIS hello is received from an OTV edge device on the site VLAN with a different site ID than the local router, the overlay is disabled. This is done to prevent any kind of loop between the OTV internal interfaces and the overlay interface. Because of this behavior, it is recommended to make OTV internal interface VLAN. It is recommended to make OTV internal VLAN the same at each site. OTV overlay adjacency. The OTV overlay adjacency is established on the OTV join interface. Adjacencies on the overlay interface are formed between sites as well as for the edge devices that are part of the same site. Edge devices form dual adjacency, which is site and overlay adjacency, for resiliency purpose. For devices in the same site to form an overlay adjacency, the site ID must match. Site VLAN, a VLAN that exists on the local site that connects the OTV edge device at layer 2. The site VLAN is used to discover the other edge devices in the local site and allows them to form an adjacency. Once adjacency is formed, the AED for each VLAN is elected. The site VLAN should be dedicated for OTV and not extended across the overlay. The site VLAN should be the same VLAN number on all OTV sites. OTV site identifier. The site ID must be the same on all edge devices that are part of the same site. The value for the site ID can range from 0x1 to 0x FF. The site ID is advertised in ISIS packets, and it allows edge devices to identify which edge device belongs to the same site. The edge devices form an adjacency on the overlay as well as on the site VLANs, which is called the dual adjacency. This allows the adjacency between the edge devices in a site to be maintained even if the site VLAN adjacency gets broken due to the connectivity problems. The overlay interface will not come up until a site identifier is configured. If a communication problem occurs on the site VLAN, each OTV device can still advertise AED capabilities across overlay to prevent an active-active scenario. But locally on the site, you might see a partial adjacency. The dual site adjacency also has a mechanism for advertising AED capabilities on the local failure to improve convergence. If the join interface on one of the AED goes down, the AED role shifts from one edge device to the other, and the other becomes the AED for all the VLANs. The same thing happens with the internal VLANs if they are down. If the internal VLANs are down, in that scenario, using the overlay interface, the AED informs the other edge device, I am not AED capable, and the AED role for all the VLANs moves to the other OTV edge device on the site. While the AED is down or initializing, and the other edge device is the AED for all the VLANs, when the edge device comes back up after initializing, or the AED comes back up, it advertises its capability to the other edge device using the join as well as the internal interface. At that point, the full adjacency is formed between the edge devices, notifying that one of them is the AED for even VLANs and the other one is the AED for odd VLANs. While deploying OTV, it is important to note that the OTV adds a 42-byte header to the ISI's control traffic and the data traffic. Thus, when you're configuring the interfaces, make sure that you have configured the MTU value correctly. For the multicast transport, with the default MTU settings, you can send the traffic up to 1442 bytes, whereas for the unicast transport, you can send up to 50 bytes. Let's look at how the OTV header looks like in OTV 1.0. From the classical Ethernet frame, the 802.1q header is removed and replaced with the OTV shim header. At that point, the whole shim header, along with the destination MAC, source MAC, and the Ethernet type, combines to form the 42 bytes, which is added as the overhead. In OTV 2.5, the 802.1q header is replaced with the OTV header, which is the UDP, OTV header, and then your destination source MAC and Ethernet type. This all combines to form 50 bytes of total overhead on the OTV interface. Let's now look at the details of the OTV header. It is a 50-byte header and it is defined in the IETF draft. It is pretty similar to the VXLAN header, which is defined in RFC 7348. The OTV 2.5 uses the UDP encapsulation. With the UDP encapsulation, we can utilize varying UDP source ports. The destination port for UDP is 8472. Note that for OTV 2.5, we require Nexus 7000 or Nexus 7700 series with F3 line cards. OTV data encapsulation. The default encapsulation method for OTV data plane traffic is GRE based, or IP generic routing encapsulation. You can modify the encapsulation method to use UDP as well, but that requires F3 line cards on the Nexus chassis. You can do that by configuring the command OTV encapsulation format IP UDP. If you're using UDP and if you want to move back to GRE, you can use GRE. An important thing to remember while configuring OTV data plane encapsulation is that the encapsulation method should be consistent across all the OTV sites. Spanning tree and OTV. Because of how OTV is designed, there is no change to the STP topology. There's total isolation of the STP domain at each site, and thus no configuration is required to implement that behavior. The BPDUs are sent and received only on the internal interfaces and are not transmitted across the overlay interfaces to the remote sites. These are some of the basic concepts that you need to remember for OTV. Let's now look at the configuration on how to deploy OTV on Nexus 3 switches.